Okay, it has not. Okay, Amma, next topic is circuit breakers. So circuit breakers, it is a device which is used under abnormal condition or faulty condition. And under normal operating condition, this circuit breaker can be used as a switch. Okay, so circuit breaker under normal operating condition, it can be used as a switch. Under a faulty condition, it can be used as a device which can interrupt the faults. And this circuit breaker, it can make or break a circuit either manually or automatically under all conditions. Means if the even if the system is under full load condition, if it is operating under full load condition, even if no load is connected, or even if the system is operating under faulty condition. Okay, whatever may be the condition of the system, the circuit breaker can make or break the circuit. Circuit breaker can make the circuit means that is under normal operating condition when the circuit breaker is operating as a switch. Circuit breaker can break the circuit means that is the abnormal condition whenever fault occurs. So the unhealthy section of the system in which the circuit breaker is connected must be disconnected from the healthy section of the system so that the fault should not spread to the healthy section of the system. So that is called breaking. Okay, so circuit breaker can make the circuit or break the circuit, both manually or automatically. Okay, so we can even operate the circuit breakers manually, and that is possible under normal operating condition. But faults are unpredictable. We can't determine the at what instant fault will occur. Okay, we can't expect. Okay, so it's an unfortunate thing that happens. The fault is an unfortunate thing that happens. So the faults must be interrupted automatically. Okay, so circuit breaker has two functions. It breaks the circuit automatically whenever fault occurs, and it makes the circuit either manually or automatically under normal operating condition. Okay, circuit breaker will be having two contacts. One is fixed contact, other one is the moving contact. So under normal operating condition, both the contacts of the circuit breaker will be in contact with each other. Under abnormal condition, the moving contact will automatically move away from the fixed contact. Okay, so this is a circuit breaker. This is a circuit breaker. So let us see the principle of operation of a circuit breaker. Okay, so as I have already told you, it consists of a fixed contact and a moving contact. You can call this fixed contact and moving contact. This is moving contact, this is fixed contact. You can see here in this image. You can call these two contacts as the electrodes. Okay, so under normal operating condition, so under normal operating condition, these two contacts will be in contact with each other. They remain closed, okay, and will not open automatically until and unless the system becomes faulty. Okay, so these two fixed contact and the moving contact, they will remain in closed position, and they will not open automatically until and unless the system becomes faulty. The contacts can be opened manually or by a remote control whenever desired. Okay, so you can operate it as a switch, I have told you. So whenever you want, you can either open it manually or with the help of a remote control. So if fault occurs in the system in which the circuit breaker is connected, if fault occurs in any part of the system, the trip coil of the circuit breaker gets energized and the moving contacts are pulled apart or away by some mechanism. An arc is struck between the contacts. So as I already told you, if fault occurs in any part of the system, okay, to which the circuit breaker is connected, so for when fault occurs, what will happen is the circuit breaker moving contact is connected to the trip coil. The trip coil is in the trip circuit. The trip circuit is having a moving contact, another moving contact. That moving contact is with respect to, or it is connected to a relay coil. Okay, I hope you know the operation of the relay. You basic operating principle of a relay, basic circuit I have already explained about it. So whenever fault current flows, the relay gets energized, the relay coil gets energized. Whenever relay coil gets energized, the trip circuit gets closed. Whenever trip circuit gets closed, trip coil gets energized. Whenever trip coil gets energized, it will pull away the moving contact away from the fixed contact. Okay, so that we have already discussed in the earlier classes. So, as soon as moving contact is moved away from the fixed contact, what will happen is an arc is struck between the contacts. You can see an arc here. Okay, as soon as moving contact starts moving away from the fixed contact, okay, so an arc is struck between the contacts. So this arc, okay, will continue the flow of current from one contact to the another contact. So actually, the current was flowing from one contact to another contact because they were in contact with each other. Okay, so and as soon as one contact has moved away from the another contact, in between, the medium should act as a direct medium, and current should not flow from one contact to another contact. Means there should not be any discharge of electrons from one contact to another contact. But it is observed that whenever circuit breaker contacts open, an arc is struck between the contacts. So that means that the circuit is not breaking immediately. Okay, so whatever arc that is struck between the contact, it will remain for short duration of time, short interval. Okay, so it will persist for short interval of time. Okay, so the even though moving contact has it had moved away from it, the fixed contact, there is discharge of electrons. Okay, so this production of arc not only delays the current interruption process, but it also generates enormous heat which may cause damage to the system or the circuit breaker contacts itself. Okay, so what is observed that when moving contact is moved away from the fixed contact, the arc is struck between the contacts, and this arc will generate enormous heat. Because of that heat, the circuit breaker contacts may get damaged, or the system to which the circuit breaker is connected, that system itself may get damaged. Okay, so the main problem in the circuit breaker is to extinguish the arc. So we must remove this arc, we must extinguish the arc, or we must quench this arc. Okay, so as soon as possible. Okay, as soon as possible we must extinguish this arc. Okay, within the shortest possible time, so that the heat generated by it may not reach to a dangerous value. Okay, so if this arc persists for longer duration of time, the heat generated by it will reach to a very high value, and it may cause damage to the parts of the circuit breaker as well as to the it may damage the system itself. Okay, so the arc must be quenched as quickly as possible. Okay, so these contacts, that is the moving contact and the fixed contact, they are placed in a closed chamber containing an insulating medium. Okay, it is these two contacts are placed in a closed chamber containing an insulating medium. That insulating medium, it can be a liquid or a gas. Okay, so the purpose of placing these contacts in an insulating medium is to extinguish the arc. Okay, so you people already know in our laboratories we will use the switches. Okay, to make the circuit or to break the circuit, we will use the switches. So you can, whenever switch is closed or open, you can see a small spark up. Okay, so that spark is nothing but discharge of electrons. Okay, so let us discuss much more about these insulating mediums. That is, it can be an air or a gas. Okay, so insulating fluids or mediums we will call insulating medium. Okay, so we can even call them as insulating fluids. Okay, so the insulating fluids in the circuit breaker chamber in which circuit breaker contacts are placed and filled with insulating medium. So these insulating medium, it can be an air, okay, at atmospheric pressure, or it can be a compressed air which is surrounding the circuit breaker contacts. It can be oil which can produce hydrogen for arc extinction. It can be a high vacuum, or it can be SF6. Okay, so SF6 gas. Okay, so these are the different types of mediums in which circuit breaker contacts are placed, in either in air or in compressed air or in oil or in vacuum or in SF6 gas. Okay, so the function of these insulating mediums is that they must extinguish the arc that is struck in between the contacts. As soon as the moving contact moves away from the fixed contact, they must be able to extinguish the arc, as well as they must act as an dielectric medium between the contacts. Okay, they must act as an dielectric medium between the contacts. So you can see here, this is the fixed contact, this is the moving contact. So moving contact has moved away from the fixed contact. So this dotted line, straight dotted line is nothing but the arc. Okay. So this is the dielectric oil. So the dielectric oil that is surrounding the fixed contact and the moving contact. So when this dielectric oil comes in contact with the arc, since the arc produces heat, it generates heat, so the oil gets vaporized. Oil vapor bubbles, you can see this white portion of oil vapor bubbles. Oh, okay, so this is the operation. In detail we'll discuss later on. Okay, so let us see the properties of this insulating fluids. Insulating fluid should have high dielectric strength. It should be non-inflammable. It should have high thermal stability. It should have arc extinguishing ability. It should be chemically stable, and it should be available at moderate cost. Okay, so if an insulating fluid or the medium that is used for the circuit breaker satisfies these properties, then only it is used as the dielectric medium or insulating medium of the circuit breaker. Okay, so it should have high dielectric strength, it should be non-inflammable, it should have high thermal stability, it should be able to extinguish the arc or quench the arc, should be able to quench the arc, and it must be chemically stable, and it must be commercially available at moderate cost. Okay, so let us see the properties of the different insulating mediums one by one. Okay, let us see the properties of different insulating mediums one by one. So if I consider a gaseous air, okay, if I consider the air, okay, so it is the cheapest and most widely used for circuit breaking. Okay, so whenever I say circuit breaking means interrupting the arc, okay, or quenching the arc. Okay, so for quenching the arc, so most cheapest and most widely used insulating medium is the gas. Not gas, gaseous air. Okay, is the air. Okay, so now let us see properties of hydrogen as insulating fluid. Okay, so hydrogen has better arc quenching property and lower dielectric strength when compared to air. This is the property of the hydrogen. If I am using hydrogen as the insulating arc quenching medium for the circuit breaker, it is observed that it has better arc quenching property, but its dielectric strength is less than air. And if I consider next, let us see the properties of the SF6 sulfur hexafluoride. Okay, So it is the best insulating medium when compared to all other insulating mediums. SF6 is the best insulating medium. Okay, and it has good dielectric strength. So it is the preferable. Of course, it is a bit costly when compared to all other insulating mediums. SF6 is the it has the outstanding arc quenching property and it has good dielectric strength. Okay, next let us consider nitrogen gas. Okay, nitrogen has similar properties to that of air, means its arc quenching property as well as dielectric strength are similar to the air. Next, let us see the properties of carbon dioxide. Okay, so the carbon dioxide has same dielectric strength that of the air, but but better arc quenching medium at moderate currents. Okay, so at moderate currents, carbon dioxide has better arc. It is the better arc quenching medium when compared to air. Okay, so at moderate currents. So let us consider this oxygen. Okay, property of the oxygen when it is used as the insulating medium. Okay, it is observed that it has good extinguishing medium but chemically active. Okay, so it is a good extinguishing medium. Okay, it has good arc extinguishing property but it is chemically active. Okay, so these are some examples of insulating mediums along with their properties. Okay, so let us go into our topic, arc phenomena. So we already know that under normal operating condition, what will happen? The circuit breaker contacts will be in contact with each other. They will be in contact with each other, and normal current will flow through these contacts. So whenever abnormal condition occurs, that is, whenever fault occurs, so the circuit breaker contacts will start to separate. Of course, both the contacts will not move at a time, but only the moving contact will start moving away from the fixed contact. Okay, so as the moving contact is moving away from the fixed contact, the contact area between, see, these two surfaces are in contact with each other for the fixed contact and the moving contact. Okay, the contact area between these two contacts is gradually decreasing. Okay, the contact area is decreasing and the pressure between these two contacts is also decreasing. Okay, so the pressure between these two contacts is decreasing and the contact area between these two contacts is decreasing whenever fault occurs as the moving contact starts moving away from the fixed contact. But the resistance between these two contacts will start increasing. Okay, the resistance in between these two contacts will start increasing, but that resistance will be very low value. It will be around 1 ohm only. Okay, the resistance between these two contacts, of course it increases, but it will be a very low value. It will be around 1 ohm. Okay, so even though the contact resistance is very small, okay, due to large magnitude of fault current, a sufficient high potential drop of around 10 power 6 volts per centimeter is caused between the separating contacts. Okay, so even though the resistance is very small, okay, because of the large magnitude of fault current, a sufficient high potential drop, voltage drop, okay, high voltage drop of around 10 power 6 volts per centimeter is caused between the separating contacts. Hence, electrons are emitted from the surface of the cathode. Okay, so so these two contacts, you can call them as electrodes. Okay, these two contacts can be called as electrodes. So one contact will act as an anode, another contact will act as cathode. Okay, one contact will act as anode, another will act as cathode. Okay, so whichever contact is acting as cathode, it will, because of this high potential drop between these two contacts, okay, what will happen? It will start emitting electrons from the surface, from its surface. Okay, so it will start emitting electrons. So hence, arc is initiated. Okay, it will start emitting electrons, hence arc is initiated by field emission. Okay, this is known as field emission. Okay, so why the electrode which is acting as cathode is emitting electrons? Why? Because of the high potential gradient between these two contacts. Okay, so because of the high potential gradient between these two contacts, okay, the electrode whichever is acting as cathode will emit electrons due to field emission. Okay, now as the contacts are moving apart, the decrease in the contact area will cause increase in the current density to very high value of around 10 power 6 amperes per centimeter square. Okay, so as the contacts are moving further and further, okay, so as the contacts are aparting away from each other, the decrease in the contact area will increase the current density to very high value of around 10 power 6 amperes per centimeter square. So these are very high current densities. Hence, what will happen is the temperature of the at the contact of cathode surface will increase. Okay, the temperature of this is our cathode. The temperature will raise to very high value that will result in thermal emission. Okay, so okay, that will result in thermal emission. So initially, due to field emission, the electrons were emitted, and due to thermal emission, the arc continues its journey from this one contact to another contact. Okay, so there will be two emissions. One emission is due to potential gradient, other emission due to high current densities between the contact surfaces. Okay, because of potential gradients, field emission occurs. Because of high current densities, thermal emission occurs at the surface of the cathode. Okay, so this high voltage gradient will exist only for few microseconds. Okay, within this short it will persist for a very short duration of time, that is within for few microseconds. Within this short period, a large number of electrons would have been liberated from the cathode, and these electrons will reach the anode on their way, colliding with the atoms and molecules of the gases, and drive energy from the field and multiply. You already know about the movement of electrons. Okay, so arc is in, and hence arc is initiated due to field effect and maintained due to thermal effect. Okay, so arc is initiated due to field emission. So field emission occurs due to potential gradient. Okay, and due to thermal due to high current densities, thermal emission occurs. Okay, and whatever electrons that are emitted here, they will be jumping. They will be colliding with the gases that are surrounded here. Okay, and they will give out energy. They will drive energy, and they will be moving forward. Okay, hence arc is struck between the contacts. Okay, so initially the arc is initiated due to field effect, field emission. Due to thermal emission, the arc is maintained. Okay, so this arc path is purely resistive in nature. Okay, so it is observed that arc path is purely resistive in nature, and generally the circuit breaker contacts will be made up of copper. Okay, so if you are able to follow or not, I don't know. If you are unable to follow, you can ask me. Okay, so it's very simple concept. It's a very simple concept. Okay, so you can see here an arc is struck between these two contacts. Here SF6 gas is this chamber. This is the chamber in which moving contact and fixed contact is there. Okay, so moving contact and fixed contacts are there, and as soon as arc is initiated due to field emission, due to thermal emission, arc is maintained here. As soon as the contacts are opening, the SF6 gas is moving towards the arc. Okay, the gas is moving towards the arc. So this is the means this whole whatever this orange color, whatever you can see is the insulating medium or insulating fluid here. Okay, of course it is not fluid because it is the gas. Okay, it is the insulating medium. Okay, so This insulating medium will come in contact with the arc and it will try to take away the heat from the arc. How arc is extinguished, I will discuss. Okay, how arc is extinguished, I will definitely discuss next later on. Okay, so now, so this arc is purely resistive in nature. That's what we have learned just now. Okay. So as the contacts of the circuit breaker apart, an arc is struck, you already know. Okay, so the voltage that appears across the contacts of the circuit breaker, okay, the voltage across the contacts of the circuit breaker, you can call it as arc voltage. Okay, voltage across the circuit breaker contacts. These are the circuit breaker contacts, moving contact and fixed contact. The voltage between these two contacts, you can call it as arc voltage. Okay. You can call it as arc voltage. So for moderate values of currents and voltages, the arc characteristics can be expressed by Artern's equation, that is EA is equal to A plus B by IA, where EA is the arc voltage, IA is the arc current, A and B are the constants. Okay, so Mr. Artern, okay, so according to Artern's equation, okay, the moderate values of currents and voltage of arc can be arc characteristics can be obtained. Okay, so based on this equation, you can say that the arc voltage and arc current are having inverse characteristics, isn't it? Based on this equation, we can say that the arc voltage and arc current are having inverse characteristics. Okay, so that means that when arc voltage is high, arc current is low. When arc current is low, arc voltage will be high. Okay, so A and B are constant. They will linearly, they vary linearly with respect to the arc length. Okay, A and B, which are constants, they vary linearly with respect to the length of the arc. Okay, so as the moving contacts are, as the moving contact is moving away from the fixed contact, the length between the length of the arc is gradually increasing. Okay, so the constant A is given by alpha plus. So it is also denoted with respect to the some constant values. Okay, so it is expressed, A and B are expressed by these expressions. Okay, so of course we are not going to implement them anywhere to determine any values. Okay, so if you say this is the arc voltage and arc current. Okay, so if you carefully observe this graph, okay, so the waveforms of the arc voltage and arc current, whenever the arc voltage is almost constant throughout the through in means during each cycle, the arc voltage is almost constant. So when current is zero, okay, arc current is zero, at that particular instant the voltage is maximum, arc voltage is maximum, and it remains constant. Okay, so and even though current reaches to its maximum value, okay, even though the current reaches to its maximum value, the arc voltage will remain same. Okay, it will neither decrease or increase, it will remain same. So again, when current reaches to the zero value, current 0 point, this is the current 0 point, arc voltage is maximum. Okay, so so this is arc voltage and arc current with respect to time actually. So you can observe here carefully, if you are observing this waveform, you can see that both the arc voltage and arc current are purely resistive in nature. They are in phase to each other. If you observe carefully, they are in phase to each other. Voltage and current, if they are in phase, that means that they are purely resistive in nature. So the magnitude of arc voltage will be very low. In few percent of the rated voltage, it can be 3% of the rated voltage. Okay. So the magnitude of the arc voltage actually from one loop to another loop, it gradually increases. It's not shown in this figure, but the magnitude will be gradually increasing, but it will remain constant throughout the loop. Okay. So when compared to this loop, in this loop, this length must be much more. Okay, in this loop it must be more. Okay, the length, this straight line must be larger than the previous one. Okay, so from one loop to another loop, from successive current loops, okay, the magnitude of the arc voltage will be gradually increasing. This is because circuit breaker contacts are assumed to be separating, thereby increasing the arc length and therefore arc voltage. Okay. So as the circuit breaker contacts are aparting from each other, okay, as the arc length increases, arc voltage also increases. Okay, as the arc length increases, arc voltage also increases. So this is about the arc phenomenon. In the next class, we'll discuss about arc interruption, how to interrupt the arc. I hope you have understood how arc is initiated and how arc is maintained. Okay, so what is the relation between the arc voltage and arc current? Arc voltage and arc current will be in phase with each other because they are purely resistive in nature. For each current loop, the magnitude of arc voltage will remain constant, but one current loop to the next successive current loop, the magnitude of arc voltage will be gradually increasing. Why? Because the length of the arc is gradually increasing. Okay. So I will stop here.